Welcome to this explainer. I am absolutely thrilled you're here. Look, if you're gearing up for the Cambridge IGCSE Physics 0625 exam, you are in exactly the right place. Today we're doing something radically different with how you study. We're going to treat mastering your exam answers like a high-end fashion designer treats a custom suit. Think about it for a second. A top-tier answer isn't just thrown together from a random pile of memorized facts, right? Just like a bespoke suit isn't bought off a rack, it's deliberately stitched together step by step, perfectly tailored to the exact question in front of you. We're going to use a concept-first approach today to look at recording motion fundamentals, making absolutely sure your answers have zero loose threads. Oh, and before we really get moving, subscribe to our YouTube channel, Ace the Exams, _IGCSE, to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Okay, let's dive into this.
So, before we start throwing formal physics vocabulary and equations at you, we got to start with a core, concept-first starter question. Why do we even need to record motion in the real world in the first place? We have to make this concept feel completely necessary, not just like some decorative math. Without understanding how to record motion, we literally couldn't design safe crumple zones in cars. We couldn't predict the orbit of satellites, and we couldn't even calculate when a commuter train is going to arrive at the station. Understanding this fundamental why makes you far less dependent on memorizing exact wording and way more capable of reasoning your way through those tricky, unfamiliar exam questions.
Now, this right here perfectly shows the difference between an average student and a top-tier one. Check out the left side. Notice the isolated fact approach. This is the student who just blindly memorizes a formula, crossing their fingers and hoping it fits the question. Now look at the right side. We have the cause and effect approach, where the physical effect is actually explained. A memorized formula. That's a weak, untailored answer, and trust me, the examiner sees right through it. But a cause and effect explanation, that is a strong, tightly tailored response that immediately proves your deep understanding of the physics at play. This right here is the main exam trap, and we're going to make sure you avoid it completely.
Okay, so let's dive into our roadmap for today. We'll start with the physics exam trap, then move into our four-step master framework. After that, decoding recording motion, mastering cause and effect, and we'll wrap it all up with the quick recall test.
Starting off with Section 1, the physics exam trap.
You know, it's incredibly frustrating when you actually know the physics, but you still lose marks. Why is that happening? Well, the answer is right here in these common weaknesses. Examiners see these exact mistakes all the time. First up, writing the correct formula without explaining the variables. Listen, just writing V equals D over T doesn't actually prove you know what those letters represent out there in the physical world. Second, quoting a process without linking it to a physical effect. And third, giving real-world examples without showing exactly why they follow from the physics. Think of these like loose threads on a suit. They might seem like minor details, but examiners will pull on them and your entire answer just unravels. If you don't tailor your answer by linking the math directly to physical reality, you're going to be penalized.
Moving on to Section 2, the four-step master framework.
To permanently stop those loose threads, you need a foolproof pattern to follow. Step 1. Identify or define the quantity or phenomenon. Basically, what are we actually talking about here? Step 2. State the relationship involved. This is where your formulas and rules come onto the scene. Step 3. Explain the underlying physics. Why does this relationship even exist? What's physically happening? And finally, Step 4. Connect it to an observation, an experiment, or a practical application. The absolute best IGCSE-style answers show both deep theoretical understanding and practical application. If you stitch these four steps together every time, you are creating a masterpiece that examiners will literally love to grade. And hey, stop scrolling. Subscribe to our YouTube channel Ace the Exams at @acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing and turn on all notifications so you never miss a strategy session.
All right, Section 3, decoding recording motion.
Okay, we're shifting gears from everyday language into strict, precise physics vocabulary. Here is our core definition. Recording motion is the physical measurement and prediction of movement using specific quantities, relationships, and principles. Notice how incredibly careful that wording is. We're measuring what's happening right now in order to predict what's going to happen next using strict physical rules. This is your foundation. Because before you can explain the physics, you have to actually be able to measure the core concept. It's the absolute equivalent of measure twice, cut once in the tailoring world.
What's honestly wild is how widely this one single concept applies. Depending on what chapter you're in, recording motion fundamentals pop up in experiments, structural engineering, safety protocols, transport, energy systems, communications, medical tech, and even astronomy. To be a top-tier student, you've got to always be ready to name at least one of these real situations where the concept actually matters. But more importantly, you need to be able to explain how the physics of recording motion helps us predict or improve outcomes in that specific field. That's exactly what Step 4 of our framework looks like in action, connecting it right back to the real world.
Let's hit Section 4, Mastering Cause and Effect.
Now, this is arguably the single most critical engine for mastering this exam. We're leaving isolated, memorized facts behind forever. I absolutely love this quote from our source material. Insist on cause and effect rather than isolated facts. This needs to be your golden rule, your personal mantra for literally any question involving fields, forces, particles, circuits, or waves. When you're asked to explain a phenomenon, the examiner isn't looking for a random list of physics trivia. They want to see the chain reaction. A causes B, which directly results in C. If you can clearly articulate that chain, boom, you've mastered the concept.
And here is exactly how cause and effect applies to visual data. Whenever a topic involves graphs, like distance time or speed time graphs for recording motion, you absolutely cannot just describe the geometry of the lines. You must explicitly state what these four elements mean physically. What's the physical meaning of the slope? Does it represent speed, acceleration? What about the physical meaning of the area under the line? Does that represent distance traveled? What does the direction or the shape of the curve actually tell you about the cause and effect chain of the moving object? Connecting the abstract math on that graph to the physical reality of the motion is exactly how you lock in those top marks.
Finally, Section 5, the quick recall test.
All right, you've learned the framework, you know the traps. Now let's look at the ultimate self-test to use right before you walk into the exam hall. Think of this matrix as your final fitting. It's a set of 4 simple, rapid-fire revision prompts. For any micro topic, like recording motion, ask yourself these 4 things. 1. What is the core idea? 2. What changes physically? 3. What quantity or graph actually shows it? And 4. Where is it used? If you can answer these 4 prompts aloud, clearly and confidently, then your conceptual understanding is locked in. You are perfectly tailored and ready for any short answer or structured question Cambridge can possibly throw at you. And by the way, students who implement these physics strategies see massive improvements in their grades, but only if they practice consistently. So here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCE, to excel in your Cambridge examinations. Don't let another exam pass you by without the right strategy.
So, I'm going to leave you with this final thought. Are you just memorizing formulas off the rack, hoping they just happen to fit the question? Or can you expertly tailor the physics to fit the real world, ensuring there are absolutely 0 loose threads in your exam answers? Utilize this blueprint, follow the 4-step framework, insist on cause and effect, and you'll be well on your way to perfect marks. Drop a comment below with your target grade for physics and the biggest challenge you're currently facing. Our team responds to every comment. Like and share this explainer with a study partner. Ace the Exams. Your Cambridge success starts here. Keep learning, keep questioning, and I'll see you next time.